Alright, ladies and gentlemen, here's the next math problem we're going to work out tonight. We've got to find the equation of an ellipse whose foci are at negative 3, 0 and positive 3, 0 with a major axis of 8 units. Now, that's important to us, and I'll show why in just a second. Again, I'm going to kind of slightly graph, and I've got my y-axis, I've got my x-axis, 1, 2, 3, 0, and 1, 2, 3, 0. So you can see I've got the foci graphed. Now, when they tell me that the major axis is 8 units, I have to envision from class when we had the two tacks and the string and we were able to draw the ellipse all the way around, and we said that that was a constant distance. In class it was 20 units. Right now we're talking about it being 8. So imagine me taking my pencil and string and drawing all the way up over and coming down to somewhere around over here. And I have to make sure that that adds up to 8 units along the major axis. So I've got 1, 2, 3, 4, 5, 6, 7, plus the string from here to here, so 8. So it looks like that major axis distance that they're telling me is also going to be the sum of the two square roots that, if we pick that point up here, and we've got the slope triangle this way and the slope triangle this way, those two hypotenuses, the sum of those has to equal 8 also. So let's start off by setting up the equation. 8 equals, and again that's the major axis distance. Now, if you remember, the foci are at negative 3, 0 and positive 3, 0. And again, we have to ask ourselves the questions when we're setting up these big square roots is, how do we get those foci points back to 0, 0? For this one, it's not that bad because we've got x plus 3 for the negative 3 squared plus y squared. And in the other equation, we have x minus 3 squared plus y squared. And again, because I'm taking that x coordinate at negative 3, 0 and moving it back to the origin 0, 0, x plus 3 gets the 3 back to 0, the negative 3 back to 0. I don't have to do anything to y because it's already at 0. And same thing over here, because I've got x plus 3, well, I want to subtract the 3 from it to get it back to 0, and obviously that's at 0 there also. Now you can see this is kind of an ugly algebra problem because we've got two square roots and an 8. We're going to have to take the square root twice, or excuse me, square everything twice because of the two square roots. First things first, however, I'm going to take this square root and I'm going to move him to the other side, just because if I try to square both sides right now, this will become a very ugly foiling problem. Obviously 8 squared is only 64. So if I move it over, 8 minus the square root of x minus 3 squared plus y squared equaling, and then that remaining square root, x plus 3 squared plus y squared. Now this is something I can work with a little bit better when I square everything. Over here to start, we've got 8 squared, which is going to be 64, minus, and keep in mind this is 8 minus this ugly square root mess in two different sets of parentheses. I'm going to do 8 minus the square root and 8 minus the square root. So you can see that when I FOIL this out, or when I use the box, you're going to get this 8 times the negative square root and this 8 times the negative square root. So you're going to getting a negative 16 square root, and I'm just going to write mess in here for now just to keep the place. And then the last part squared out of the original foiling is going to be the square and the square root canceling out, leaving me with that plus x minus 3 quantity squared plus y squared. Now again, just to recap, we've got 64 minus 16, the ugly square root, plus, and then the stuff that's left inside the square root because we're squaring the first and last terms. On the other side, however, where the algebra gets nice and easy, the squared and the square root cancel out, leaving me x plus 3 squared plus y squared. So now we've got to go through and simplify all the stuff that we have going on here. Well, nice thing first, y squared and y squared, those guys cancel out. So let's go back over here. 64 minus 16, and I'm going to write the rest of that square root in now. X minus 3 squared plus y squared plus, alright, we've got x minus 3 quantity squared. It's going to be x squared minus 6x plus 9. Make sure you don't forget about that negative 6x. And then this is going to equal our x plus 3 squared, which is x squared plus 6x plus 9. Well, again, we got a couple of nice things happening here. X squareds cancel out, plus 9s cancel out. So now I'm left with 64 minus 16 times the square root of that mess. Got a minus 6x lying around in here, and then a plus 6x on the right-hand side of our equation. So now what I'm going to do is I'm going to kind of try to isolate this x, or the square root over here, by taking the 64 and the 6x and moving them over on this side of the equation. So minus 64 plus 6x, got a minus 64 and a plus 6x. Negative 16 square root x minus 3 squared plus y squared. And I want you guys to keep in mind while I'm doing this, I've got a 12x minus 64 over here. And one thing you have to keep in mind while we're doing this is that as much of an ugly algebra problem as it is, just keep on trusting our algebra skills, because eventually this puppy is going to pan out to be something really nice for us. Again, to try to work on isolating this square root, I divided off a negative 16 off of both sides. So now I can see we've got square root x minus 3 squared plus y squared equals, and this stuff, well, I know that 12x and 16, 12 and 16 simplify down to 3/4. So I'm going to negative 3/4 x, and then 16 and 64 simplify to 4. Well, now this problem looks like it's getting to be quite a bit easier. We've got the square root of x minus 3 parentheses squared plus y squared as a whole square root minus 3x plus 3/4 x plus 4. Now we're going to look at squaring both sides of this. Square and square root cancel out, leaving it x minus 3 squared plus y squared equaling, well, negative 3/4. If you think about multiplying or putting these two into two binomials, negative 3/4 x plus 4 times negative 3/4 x plus 4. You have a negative 3/4 times negative 3/4, which is a positive 9/16 x squared. And you multiply 4 and this together. Again, this is the inside-outside of my foiling, or if you have the generic rectangle drawn to do this, you've got 4 times the negative 3/4 in there at some point. So we've also got, well, let's see, that's going to cancel out, leaving me with a minus 3x. And I'm going to have 2 of those for the inside and outside of my foil. And then I've got plus 16 over here, as in the 4 squared. So going back over here, we've got, well, we're going to multiply this binomial out, x minus 3 quantity squared. It's going to give me x squared minus 6x plus 9 plus y squared equals 9/16 x squared minus 6x plus 16. Nice thing happens again, the 6x and 6x cancel out. Now you can see I've kind of got my ellipse starting to take form. I've got my x squared, I've got a y squared, I've got some other x squared over here, 9 and 16. Well, I'm going to move the 9 over right away. And in the ellipse, in the ellipse we want everything to equal 1. So if I start getting constants on this side, and my x squared and y squared over here, that should get me closer to that form. I'm going to subtract the 9/16 x squared. And again, keep in mind that if we just focus on trusting our algebra skills throughout this process, it'll get better real quick. Over here I've got 1x squared minus 9/16. Well, let's think about this one as being 16/16 minus 9/16. It's going to leave me a 7/16 x squared plus my y squared. He hasn't gone anywhere. And that's going to equal 16 minus 9, which equals 7. Divide everything by 7, because again I want to make sure that this equals 1 for this to actually be an ellipse. Well, this 7 and 7 are going to cancel out right here, and here just leaving me x squared over 16. And I've got a y squared over 7. And then we've got this equaling 1. So x squared over 16 plus y squared over 7 equals 1. And you can see on here that